Fuels and their effects on cars. Customers do not just want reliability from cars today. Economy is increasingly taking center stage. Despite the most detailed maintenance and servicing, some chemical and physical reactions with their associated problems cannot be avoided. For example, water and moisture are found in any fuel system, but how do they get there? To illustrate this, we need to have a look at the inside of a fuel system. As people drive their cars, the level of fuel drops in the tank. Fresh air is sucked in via venting equipment to equalize the pressure in the tank. This air contains more or less moisture depending on the prevailing weather conditions. As a result of temperature fluctuations, for example, when darkness falls, condensation is formed from the moisture in the air and is deposited on the walls of the tank in the form of drops of water. As water has a higher specific density than fuel, that is to say, it is heavier, this condensation gathers at the lowest point in the tank, at its base. But this is not the only way for water to make its way into a fuel system. When people fill up their cars, condensation that has settled in the petrol station's large tank may get into the car's fuel system. Or water may enter as a result of the weather, heavy rain or splashes, or when people wash their cars after it has become very dirty. This creates the following problems. Water in the fuel system leads to less lubrication and therefore to higher wear and noise from the fuel pump, to quote just one example. The water triggers a corrosion process in the whole fuel system. Corroded and loose rust particles can reduce the diameter of pipes and do serious damage to the way the fuel system works. Some of these rust particles are stopped by the fuel filter, but the water still gets past the filter without any problem and causes further rust in the components downstream. These rust particles can then break off and cause major problems. In our example, the fuel pressure regulator, the fuel distributor, and the injector nozzles are all seriously impaired. When injector needles jam, combustion continues in an uncontrolled manner. And any drops of water which reach the combustion area trigger faults in the combustion process. And further problems are created by a change in the fuel composition, as shown here. In lead-free fuels, the lead has been replaced by alcohols. Alcohol does not have any lubricating properties and is also hygroscopic, that is to say, it attracts water. As a result, the problems described here, water and moisture in the fuel system, are made even worse. As they pass through the fuel, the condensed drops of water extract the alcohol and form a highly aggressive alcohol-water mixture on the base of the tank. The fuel pump then ensures that this is distributed through the rest of the system. This highly aggressive alcohol-water mixture then passes through the fuel filter unhindered and has a destructive effect on all the component materials downstream. Aluminium parts are particularly at risk. Aluminium hydroxide can be formed in them and is well known as a white powder. But cast metal parts, elastomers, fuel pipes and piston heads and rings are just as much at risk. This alcohol-water mixture and the rust particles which it causes lead to greater wear and material migration in the types of components mentioned here. The pressure conditions in the fuel system are also disrupted by any restriction in the diameter of the fuel lines. In the long term, gaskets corrode, are damaged and therefore don't work properly. The amount of alcohol added to fuel is an important parameter for determining its anti-knocking properties. As alcohol is hygroscopic and forms a compound with the condensed water, the proportion of the alcohol in the fuel is reduced. This leads to a drop in the fuel's anti-knocking properties and the engine may ping or knock during the combustion process. There may be an increase in combustion residue, and in the long term, damage occurs to the engine. Water continually forms and settles in the fuel system, and it is impossible to prevent this. There is a much more familiar problem being created at the same time. Petrol companies and vehicle manufacturers point out that deposits and contamination will form in the whole fuel system as a result of the fuel put into the engine. These deposits are caused by parts of the fuel that are broken down and may be called residual gum, varnish and resin. There are a number of reasons for this, but the main reason is the breakdown or deterioration in fuels or automatic oxidation. The gum, varnish and resin deposits can easily be seen if petrol is spilt when filling up and then runs down the bodywork. Petrol evaporates, leaving brown substances, these gum, varnish and resin deposits. This fuel contamination is present as sticky remains in the tank, the feed and return lines, the intake pipes and the carburetor and fuel injectors. In short, the whole fuel system. This in turn means that the flow characteristics of the fuel change in the whole system, seen here at individual components. Deposits on the valves and intake ports constrict and hinder the flow of the fuel and the fuel-air mixture. These deposits can cause a lack of fuel in the fuel injectors and even the complete breakdown of the fuel supply. The injector nozzles jam, the uncontrolled combustion washes away the oil film on the walls of the cylinders. Thermodynamic problems result from the increase in friction. In the last resort, this leads to a poor level of efficiency, an increasing loss in power, high fuel consumption, and a greater level of pollution in the environment, as the driver consumes more fuel to obtain the same performance. And if the degree of contamination is particularly high, the engine may give up the ghost completely. Faults that only occur sporadically are a particularly serious problem, as they are hard to locate during normal testing procedures. The following operating problems may occur: starting problems, rattling noises, high fuel consumption, poor push-pull performance, and a miserable acceleration rate. What does all this mean for the car repair shop? Troubleshooting takes a lot of time and is therefore expensive because the causes of problems are so complex. Even after parts have been replaced at great cost, this may not always completely eliminate the problem. In the end, the customer is dissatisfied and switches to a different repair shop. So as to prevent drawn-out and often unsuccessful repair work, our chemical tools should be used to clean the fuel system. It is very easy to use. Regardless of how much fuel you have in your tank, you just pour the fuel system cleaner into your tank during or after a service. It is then distributed to the whole fuel system, and it breaks down all the deposits into very fine molecules. The fuel system cleaner ensures that the resin deposits and the water are bonded with the fuel. This creates what is known as a stable, flammable emulsion. The deposits that are broken down, including the water, are simply burnt in the combustion chamber without the driver noticing anything. And at the same time, highly effective lubricants protect the complete fuel system. Gaskets, elastomers and shaft sealing rings are kept pliable. This prevents any phase separation in the alcohol fuel, that is to say, the fuel does not decompose. No alcohol-water mix is created, and the fuel's anti-knocking properties are fully maintained. The effect of this product, which has been proven and certified by the German Technical Inspection Agency, is not only temporary, but provides a desirable positive long-term effect by forming a protective film in the whole system. You only need to use the fuel system cleaner once a year during the car's annual service. This creates the following effects. ideal lubrication, the best possible supply of fuel, powerful combustion, an excellent degree of efficiency, an extremely quiet engine, reductions in fuel consumption, and outstanding protection. Customers will only be satisfied and remain loyal if they obtain the best possible service when the fuel system cleaner is used in either petrol or diesel engines.